Okay, we're going to look at the derivative here of polynomial x squared minus 3x, keeping in mind the definition of the derivative, which is the limit as h approaches 0, f of x plus h minus f of x all over h. So therefore, if this is f of x plus h would be wherever I see x, I'm going to put x plus h. So it would be x plus h squared minus 3 times x plus h. So here's f of x plus h, and then here's our definition of derivative, a limit statement. Okay, so it's the limit as h approaches 0 of f of x plus h, which is this here, x plus h squared minus 3 times x plus h minus the whole quantity of f of x, so x squared minus 3x, all over h. So now we've just set up the definition of derivative. Now we have to do some algebra, squaring this, distributing this negative 3, and distributing that negative. So I get this squared is x squared plus 2xh plus h squared minus this distributed negative 3x minus 3h minus this negative distributed x squared plus 3x all over h again. Conveniently, our x squareds cancel and our 3x's cancel. If your non-h terms do not cancel, then you did something wrong. You should only be left with terms in terms of h, because we want this h to cancel out. So part 2 is if this h doesn't cancel out, then you did something wrong. So we're not at the canceling out point yet, but we will very shortly. So let's just write down what we have left. 2xh plus h squared minus 3h all over h. Let's factor out a common factor of h. So take an h out. I get 2x plus h minus 3 all over h. My h's cancel. So let me just scroll down a little bit here, give myself a little bit more room. So we have the limit as h approaches 0 of 2x plus h minus 3. Plug in 0, and my derivative is 2x minus 3. So we just determined that the derivative of x squared minus 3x is 2x minus 3. So now let's look at a rational example. Again, the definition of the derivative, just so we have this handy, is the limit as h approaches 0 of f of x plus h minus f of x all over h. So here is my function, and here's my definition of derivative. So let's just plug in x plus h. So I get x plus h over x plus h minus 2 minus f of x, which is this function here, all over h. Easiest way I find to do these problems is when I have a complex fraction, I determine what the common denominator is and multiply both the numerator and denominator by the common denominator. So I'm going to multiply this whole fraction by the common denominator. Well, the common denominator is x plus h minus 2 and x minus 2. So I'm going to multiply it by x plus h minus 2, x minus 2, but I need to use the property of 1, so the whole denominator is going to get multiplied by the common denominator as well. So I'm using the property of 1. So now this whole thing gets multiplied by this. Hopefully you notice that this x plus h minus 2 gets canceled. So we'll write that out just so it's clear. H approaches 0 of x plus h times x plus h minus 2 times x minus 2 all over x plus h minus 2 minus x times this piece here, this numerator again, x plus h minus 2, x minus 2 all over x minus 2 Now that is all over h. So the whole purpose of doing that is these two cancel and those two cancel. Hopefully you didn't need to see this step. Most people don't write this out, but I thought I'd write it out because there was a lot of terms here. So we have the limit as h approaches 0 of x plus h times x minus 2 minus, those two cancel, so x plus h minus 2. Oops. I was supposed to multiply this by h as well. So that's x plus h minus 2, x minus 2. So all over h x plus h minus 2, x minus 2. So now let's distribute this. So if I multiply this, I get x squared minus 2x plus hx minus 2h minus x squared minus xh plus 2x all over this very unattractive denominator, which I'm not going to multiply. And hopefully you'll see why in a second. So I need a little bit more room. Let me scroll down. So again, my non-h terms are going to cancel. X squared, 2x, 2x. I'm just left with 3h terms. So my computer just paused for a second. H approaches 0. hx minus 2h minus xh all over h, x plus h minus 2, x minus 2. Notice we have a common factor of h and h in the denominator. So again, if your h in the denominator doesn't cancel out, you did something wrong. So factor an h out, I get x minus 2. Oops. It's like I should have canceled out these hx's. Those two should have canceled. We should have canceled those two, so I'm just left with negative 2h. So these two h's cancel. So I'm left with negative 2 over x plus h minus 2, x minus 2. I evaluate my limit by plugging h in. I'm left with negative 2 over x minus 2, x minus 2, which is negative 2 over x minus 2 squared. So outside of that minor issue here, I forgot to cancel out the xh's. Notice that the h's cancel out, the numerator and denominator, so if that doesn't happen, you have a problem. You evaluate the limit by plugging h in for 0. There's only one h. I'm just left with 2x minus 2, so that's x minus 2 quantity squared. So our last example is a radical function. So our definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So my limit as h approaches 0, 2 times x plus h plus 3 minus 2x plus 3 all over h. Just like with limit problems, back in your limit section, when you have a radical and you're dealing with limits, a lot of times, that's an h by the way, a lot of times it's convenient to multiply by the conjugate. So in this case, the conjugate is going to be 2 times x plus h plus 3 plus the quantity 2x plus 3 all over 2x plus h plus 3 plus 2x plus 3. So the convenient thing when you're multiplying by the conjugate is you lose your middle term, so it's really just this one times this one, so the radicals cancel. The second term is multiplied by each other as the radicals cancel. So I'm just left with 2x plus h plus 3 minus the quantity 2x plus 3 all over. I'm not going to multiply h through, because it doesn't help me. X plus h plus 3 plus 2x plus 3. Distribute this 2, distribute that negative. I get 2x plus 2h plus 3 minus 2x minus 3 all over that big ugly denominator again. These 2x's cancel, the 3's cancel. I'm just left with 2h. So 2h over h times the radical 2 times x plus h plus 3 plus square root of 2x plus 3. Again, if these h's don't cancel, you made a mistake. So I'm just left with the limit as h approaches 0 of 2 over the square root of 2 times x plus h plus 3 plus the square root of 2x plus 3. I sub 0 in because I'm determining the limit as h approaches 0, so that h goes away. So I'm just left with 2 over 2x plus 3 plus the square root of 2x plus 3. And let me just get a little bit more room here. Notice that I have two terms here that are the same. So I get 2 over 2 the square root of 2x plus 3. Those two cancel, and I'm left with 1 over the square root of 2x plus 3. So there you have it.